Hello, I'm Brian Farrell, and welcome to PACE IT's session on Storage Devices Part 2. Today we're going to discuss the anatomy of a hard disk drive, then we're going to talk about some aspects of the traditional hard disk drive, and then we're going to cover some items about solid-state drives. There's a fair amount of information to cover, so let's go ahead and begin this session. And of course, we begin by talking about the anatomy of a hard disk drive. So hard disk drives are composed of various components, including multiple metal disks that are called platters. These are held in place by a spindle which rotates the platters. Then there's the armature, which moves the read head across the platters to read and write data to the drive. Getting a little deeper into the anatomy of a hard disk drive, well, the platters are logically broken up into tracks. Think traffic lanes, in which the data is electromagnetically laid down. The tracks are logically broken up into sectors, think addresses, in order for the PC to know where the data is located. Now, the faster the platters spin, the faster the drive can read and write data. Common spin rates range from 5,400 RPM all the way up to 15,000 RPM. But in the consumer market, you're more likely to see the 5,400, the 7,200, or the 10,000 RPM hard drive. In the enterprise market, you're much more likely to come across the 10,000 RPM or the 15,000 RPM hard drive. So now let's move on to some other aspects of the traditional hard disk drive. And we're going to begin with its traditional interface to the motherboard, and that would be the parallel AT attachment, PATA. Now this could use either the Integrated Drive Electronics, IDE, or Extended Integrated Drive Electronics, EIDE, interface on the motherboard. The actual interface connection on the motherboard was a 40-pin connector. Now, if the motherboard only supported IDE, a 40-wire, 40-pin ribbon cable was used to connect the hard drive to the motherboard. If the motherboard supported EIDE, an 80-wire, 40-pin ribbon cable was used, and higher transfer speeds were achieved. The maximum speed, or rate of transfer, of a PATA drive was 133 megabytes per second. Now, power was supplied to the hard drive through a 4-pin Molex plug. Now, with the PATA interface, a master-slave relationship was used to determine which hard drive was bootable when multiple devices were present on the same ribbon cable. The master-slave status could be set by jumpers on the back of the hard drive. With the introduction of EIDE, there was another relationship that could be chosen, and that would be cable select. And what that meant was where the device plugged into on the cable would determine if it was the master or the slave drive. Then along came serial AT attachment, SATA. It can be used with traditional hard drives or with solid-state drives. Now it's a newer interface standard and it achieves much higher transfer rate. SATA 1.0 was capable of 1.5 gigabits per second transfers. SATA 2 was capable of 300 megabytes or 3 gigabits per second transfer, and SATA 3 has a theoretical transfer rate of 6 gigabits per second. Now on SATA, only one drive was allowed per cable, and your boot priority is no longer established at the drive, but it is set in the BIOS settings of the motherboard. Now the SATA interface uses an L-shaped connector with a 7-wire, 7-pin cable. On an interesting note, all SATA drives are hot swappable, meaning that the PC and the device do not need to be powered down in order to replace it and put a new one in. But that's of limited value when the SATA drive is inside of your PC. Now let's move on to solid-state drives. Now, solid-state drives, or SSDs, use different construction altogether. There are no moving parts. They use arrays of flash-type memory instead of spinning platters to hold the data. You can achieve faster response times with an SSD than you could with a traditional hard drive. When an SSD is used internally, the most common interface is the SATA interface. When your solid-state drive is used externally, the connection type can vary. It can be USB, or it can be eSATA, or it could be FireWire. They are faster and quieter and cooler than the traditional hard drive, but the price per gigabit of storage is much higher than with traditional hard drive. So they're not going to replace the traditional spinning platter hard drive soon, at least not until the price comes down a bit. Now, some devices are a type of solid-state drive, but they're not really considered a solid-state drive. And what are those? Well, there's CompactFlash. Now, CompactFlash is a type of removable storage. It could be considered a solid-state drive because it holds data and there are no moving parts. Now, with CompactFlash, you can hold up to 128 gigabytes of data. Then there are secure digital cards, SD cards, with a current max capacity of 2 terabytes of data. We also have the older XD standard. Now this was used in some digital cameras to hold pictures, but is now considered obsolete. Now USB flash drives could also fall into the SSD category, but not really, because people think of them as their own category. Now that concludes this session on storage devices part 2. We talked about the anatomy of a hard disk drive. We talked about some aspects of the traditional hard disk drive, and then we briefly touched on solid state drives. Now, on behalf of PACE IT, thank you for watching this session, and I'm sure another one will happen soon.